Hello students, earlier I have made a video on mole concept. This is the second video in which I will discuss some of the questions which came in previous years in JEE Main and Advanced. I hope it will help you to make your concept clear regarding the mole concept. Without wasting any time, let us discuss the questions. Question number 1. In a compound, ratio of mass oxygen is to my nitrogen is given as 1:4. Ratio of mass of oxygen nitrogen is given as 1:4. They are asking the ratio of moles. Ratio of the moles you have to find out. In solving a question you should get maximum 1 minute, so you should be quick enough to do the calculation. Look at how we are proceed to do the sums. So NO2, N means mole, by NN2. Moles is equal to mass by molar mass gives you the number of moles. Mass is given as oxygen as 32, nitrogen is 24. So 1 by 32 divided by 4 by 28 will be the ratio of the moles. So is equal to 1 by 32 into 28 by 4. 1 by 32 into 28, 1 by 32 into 28 by 4. It is the ratio of the mass is given as 1:4. Moles will be oxygen, it will be 1 by 32. For nitrogen, it will be 4 by 28. It is the mass, molar mass is equal to 28. So it will be 1 by 32 into 28 by 4. So it becomes 7. So in this case, ratio of the moles will be will be 7:32. This is the first sum. Check, I have taken within 1 minute to solve it. So you should be quick enough to solve it. Let us look at the next question. The next question is given thus: molarity you have to find out of two solutions mixing by mixing 75 ml 0.5 molar HCl and another is this 250 ml 2 molar HCl. These two solutions are mixed together to make the resulting solution. I have written 75 ml 0.0 molar HCl and 250 ml 2 molar HCl. You should use the formula M1V1 plus M2V2 equals to V1 plus V2 is the total volume after mixing into M. M is the molarity of the resultant solution. So let it take it as V1, this as M1, this as V2, this as M2. So using the formula it will be 75 into 0.5 plus 250 into 2 equals to adding 750 plus 250. Make it 1000 into M. M you have to find out. M will be 750 into 0.5 plus 250 into 2 divided by 1000. This will be the molarity of the solution. Check it. The calculation you should get as 0.875 molar. So because of this 0.875 molar, because it is the lower molarity, it is the higher molarity. On mixing these two, it will be dilute. The molarity will be in between 0.5 and 2. It is the second sum. Let us go to the third sum. In the third sum, it is given as a gaseous hydrocarbon. Hydrocarbon we have taken as CXHY. For burning it, we have to use the formula X plus Y by 4O2. It gives you XCO2 plus Y by 2 H2O. See, whatever be the number of mole atom of carbon, that is obtained as the number of moles of carbon dioxide. And in this case, whatever be the mole atom of hydrogen, half of that is coming into water. In this case, they have given us carbon dioxide mass, they have given us in this case 3.08 gram. In this case given as 3.08 gram. In this case the value is given as 0.72 gram water. 0.72 gram water. In this case, mass is given to you. Whatever be the mass of carbon dioxide, the carbon in carbon dioxide coming from the hydrocarbon. So let us find out the mass of carbon present in carbon dioxide. How you can find out the mass of carbon from carbon dioxide? Carbon dioxide having molecular mass 44. 44 means 44 gram carbon dioxide contain how much? 12 gram of carbon. So how you should proceed the sum? In this case, just find out moles of CO2. Moles of CO2 will be 3.08 divided by 44. 3.08 by 44 will be the moles of carbon dioxide. Moles of water is what? Will be 0.72 by 18, because the molar mass of water is given as 18. Let us do the calculation such that you can follow it carefully. In this case, suppose in this case 3.08 divided by 3.08 divided by 44. 44 is the molar mass of carbon dioxide. What are you getting? 0.07. It is the moles of carbon dioxide. So mole atom of carbon will also be 0.07. In this case, moles of water is what? 0.72 by 18. What it amounts to? It amounts to 0.04. Moles of water. Okay, whatever be the moles of water, mole atom of hydrogen will be double of that, because it is Y by 2 and hydrogen is Y. So moles atom of hydrogen in the hydrocarbon will be what? I have taken just a bit longer time to solve it, 0.08. So the ratio of carbon is to mole atom, ratio of carbon is to hydrogen will be 0.07 is to 0.08 equals to 7 is to 8. So the formula of the hydrocarbon will be C7H8. It is the most simplest way of solving it. Just I find out the moles of carbon dioxide. It is same as the mole atom of carbon present in the hydrocarbon. Whatever be the mole atom of hydrogen coming over here, moles atom of hydrogen in the hydrocarbon will be double of that. It's 0.04. So 0.04 into 2, 0.08. So the formula of the hydrocarbon is C7H8. This is the second sum. Second or third, whatever it is, let us move to the next sum. In the next sum, it is given as, this is a good sum because most of the sums from doing normality, molarity, this is very basic one. I haven't done it. You can expect it mains. For advanced level, I will make another video. But it is the basic things. Try to make your base clear first before going to advanced one. In this case, density of the solution is given as 1.15 gram per mole. 1.15 gram per ml. In this case, it is taken as 120 gram of urea was dissolved in 1000 gram of the solution. Density of the solution is given as 1.15 gram per ml, 120 gram of dissolved in 1000 gram solution. You have to find out the molarity of the solution. Find molarity of the solution. Molarity denoted by capital M is equal to moles of solute over volume of solution in liter. Look at how we proceed to the sum. Urea formula is NH2CONH2. Molecular weight of urea found out to be 60. This is simple one, you can find out. So moles of urea will be mass given 120 gram. by 60 gram per mole. So it is the moles. Next you have to find out the volume of the solution in liter. It is the mass of the solution. It is the density gram. Density is given as 1.15 gram per ml. In this case it is the moles. In this case volume is given as ml. You have to convert into liter. So divide by 1000. Check the calculation. Gram is the mass. It is the density 1.15 gram per ml. Ml we have to convert it in liter. So divide by 1000. So these get cancels. So in this case what it would be 120 by 60 into 1.15, 2.30 molar. So this is the strength of the solution when 120 gram of urea was dissolved in 1000 gram of the solution. Acha. Let us, I think it is we have completed the fourth sum. Taking together we have completed the fourth sum. Let us move to the fifth sum. This is also very good sum. This is from redox reaction. You know, dichromate react with ferrous salt. The reaction takes place as follows. If I write down the balancing equation, what it become? In this case, Fe2 plus loses an electron, become Fe3 plus. In a redox reaction, number of electrons given and taken are same, multiply by 6. So moles ratio of dichromate and Fe3 plus, Fe2 plus are 1:6. For 1 mole of dichromate, we require 6 moles of ferrous salts. In this case, what is given as? They are asking the mass of dichromate, which is obtained to oxidize 750 ml 0.5 molar more salt, 750 ml 0.6 molar more salt. In this case, it is given as more salt is FeSO4 NH4 whole 2 SO4. In this case, Fe2 plus oxidized to Fe3 plus. Moles ratio equals to 1:6. That is potassium dichromate and ferrous salt is more salt is equal to 1:6. Means for every 6 moles of ferrous salt we require 1 moles of dichromate. Let's see how we can solve the sum. In this case, it is given as more salt is given as 750 ml is the volume of the more salt and strength of the given as 0.6 molar. So in this case, 750 into 0.6 is equal to how much? (450 millimoles of more salt. So volume, so millimoles of Fe2 plus, millimoles of your dichromate will be what? Will be 1/6 of that. Should be 1/6 into 450 ml. 1/6 of 450 millimoles. The ratio will be millimoles and moles ratio are same. So for moles, in this case, this is the millimoles of dichromate. So moles of dichromate will be 1/6 into 450 into 1/1000. This will be the moles. Mass of dichromate will be moles should be multiplied by molecular weight. 1/6 into 450 into 1000 into molecular weight of dichromate, which is 350 which is you calculate the molecular weight of dichromate, and the actual value you should get as 20, roughly it will get 22.05 gram. Again, from the redox reaction, for every 6 moles of more salt, we require 1 moles of dichromate. We find out the millimoles of volume into molarity. When volume is given as ml, strength in molarity, multiplying together we get millimoles. Millimoles of more salt is known, millimoles of dichromate will be 1/6 of that. Convert to moles by divided by 1000. That multiplied by molecular gives you the mass of more salt. Hope you will follow it. If you don't follow, in the description box I will provide my cell number. You can contact me over there. Now next sum. In the next sum is given as, they are asking the molality of a solution of urea, where 0.100 gram of urea was dissolved in 0.3 liter of the solution. In this case you have to find out a molality of the solution. In this case, what the data they provided? In this case, data they provided as 0.100 gram urea in 3 liter, 0.3 liter, having density of the solution is given as how much? Having density 1 gram per ml. This is the density they provided. 0.3 gram is equal to 0.3 liter. 0.3 liter is equal to into 1000 gives you 300 ml, 300 gram. It is in liter. It is gram per ml. 0.3 liter into 1000 will be this. Will be the amount of ml. So 300 ml into 1 gram per ml. Sorry, it was, I have told something other. It is 300 gram is the mass of the solution. Mass of the solute is given as how much? 0.1 gram. Mass of the solute is given as 0.1 gram. So mass of solvent will be what? 300 minus, I am very sorry to say, in this case it is not given 0.100 gram, it is given as 0.10 moles of urea. So from 10 moles of urea you have to find out the mass of the solute. See, it is the case of, first of all, in the question they have asked the 0.1 mole of urea is dissolved in 0.3 liter of the solution having density 1 gram per ml. You have to find out the molality of the solution. Is it clear? 0.10 gram, not gram, moles of urea is dissolved in 0.3 liter having density 1 gram per ml. You have to find out the density of the solution. Sorry, density, the molality of the solution. Let us proceed. Mass of solution is what? Mass of solution. Volume is given as is equal to volume into density. Volume is given as 0.3 liter, multiply with 1000 gives you in ml into 1 gram per ml is equal to what it become? 300 gram. Mass of solute .100 into, it is the moles, into 60 gram per mole gives you the mass of solute in gram. What it become? How much? 6 gram. Mass of solvent (300 minus 6), that is 294 gram. As the question is molality, molality will be moles of solute divided by mass of the solvent in kg. Okay, molality is equal to moles of solute. Moles of solute is equal to what? Mass of the solute I have got as 6 gram by 60 gram per mole. This is the moles. Denominator will be mass of the solvent in kg, it is 294 gram into 1000 kg per gram. It is 294 gram into 1 kg by gram. Okay, now this get cancels. 294. Now in this case, what is how much? Just 1 minute. See, molality is equal to moles of solute, that is 6 by 60 over mass of the solvent in kg, it will be 294, it is gram, into, we have to convert it kg, so into 1 by 1000. So in this case it will be kg by gram. These get cancels. So 294 by 1000 gives you the mass of the solvent in kg. So 1 by 10 divided by 0.294 will be the molality of the solution. Calculation, you just check in. I haven't done the calculation yet. So if you tell me to what will be its value, I am telling you the value of this also. In this case it will be 0.0294. This will goes up by 10, it become 0.0294 molar. This will be the molality of the solution. I am telling you the exact answer also. Let us go to the next sum. In this case it is given as how many moles of magnesium phosphate are there in 0.25 mole of oxygen atom. In this case the case is given as mole atom of oxygen is given as 0.25. They are asking the moles of magnesium phosphate. For 1 mole of magnesium phosphate, we have 8 mole atom of oxygen. Mole atom of oxygen is given as 0.25. So mole of magnesium phosphate will be 1/8 of that. So 0.25 into 1 by 8. So 1 by 32 mole. Okay, because for 8 mole atom, 1 mole atom, for 0.25, it 1:8. So it will be into 1 by 8 gives you the moles of magnesium phosphate, that is 1 by 32 mole. Now this is the 5th or 6th, whatever be the number. See, in this case result will be 3.125 into 10 to the power minus 4. You check it, you will get the answer. Okay, 1 by 32, what it is? 1 by 32 0.03125 it will be 3.125 into 10 to the power minus 3. Now next sum. In the next sum it is given as what volume of hydrogen at HTP will be obtained when boron trichloride was reduced. 21.6 gram of boron trichloride was reduced to boron. Okay, simple sum. Let us clear the board. Look at the reaction. Three by 2 H2 gives you B plus 3 HCl. In this case, ratio of moles of BCl3 is to H2 is equal to 1 is to 3 is to 2, 1 is to 3 by 2. So whatever be the moles of BCl3, B also have the same mole atom. Okay, or ratio of the moles of mole atom of boron, moles of boron, moles of hydrogen is equal to 1 is to 3 by 2. Now in this case, mass of boron is given as 21.6 gram. Mass of boron. Moles of boron atom. (21.6) divided by 10.8 is equal to 2. Now moles of boron is to moles of hydrogen is equal to 1 is to 3 by 2. Okay, so in this case, moles of hydrogen will be, for 1 is to 3 by 2, as it is given 2 mole, so it will be 2 is to 3. So moles of hydrogen will be 3. In this case, they are asking you what volume of hydrogen at HTP. We know 1 mole at HTP, volume 22.4 liter. For 3 mole of hydrogen should occupy a volume of 22.4 into 3, that is 67.2 liter. This will be the answer of this sum. Okay. Next sum is a bit easy sum. You will be able to find it. In this case, they are asking you then, because some of the sum may require more than 1 minute, some require less than a few seconds also to solve it, 20 to 30 seconds. This is a sum in which you require a few seconds to solve it. In this it is given as 500 gram of Fe. The mole atom of Fe will be what? 500 gram by 56 gram per mole atom. When they are asking the atom, 500 by 56 into Avogadro number gives you the number of atom. This will be the number of Fe atom present in 500 gram of Fe. First I find out the mole atom, then find out, multiply by Avogadro number gives you the atoms. Let us look at the next sum. In the next sum it is given as an organic compound of molar mass 108. 108 in it carbon, hydrogen and nitrogen are present in the ratio 9 is to 1 is to 3. Molecular form of the compound they are asking. Molecular of the compound is 108 gram. It is the molecular of the compound, and in this case it is given as mole atom of carbon is to hydrogen is to nitrogen is given as how much? 9 is to 1 is to 3. So out of 13 gram, 9 gram is the mass of carbon. Out of 13 gram, 1 gram is the mass of hydrogen. Out of 13 gram, in this case we have 3 gram will be the mass of 3. In this case 3 gram will be the mass of wood, which 3 gram will be the mass of nitrogen. Let us solve it. How you can proceed to do the sum. It is also very easy sum. You can easily solve it. In this case, see how you can proceed to the sum. Mass of carbon 9 by total mass is 13 into 108. This will give you roughly 9 by 13 into 72 gram. In this case, mass of hydrogen will be 1 by 13 into 108, roughly 6 gram. For nitrogen it will be 3 by 13 into 108, 1 by 13 into 1 by 13 into 108, 9 by 30 into 108 is equal to 72 gram. In this case it is how much? In this case it's roughly 8 gram. Okay, roughly 8 gram. Wrongly I've written it is not 13, it is 13.5. On adding it, 9 is to 1 is to 3.5. In this case it is 13.5. Okay, so in this case it is 3.5. It is 3.5. 3.5 by 13 into this is equal to how much? 18 gram. Roughly it become how much? 28 gram. It is the mass of carbon, it is the mass of hydrogen, it is the mass of nitrogen. Moles of the element, moles of carbon will be 72 by 12, molar mass 6. For hydrogen it will be 8 by 1 is equal to 8. In this case it will be, for nitrogen will be 28 divided by 14 is equal to 2. So in this case it becomes C6H8N2. This will be the molecular formula of the compound. In this case it is the mass given, ratio of mass given, mass of individual element I find out of 13.5 gram, 9 gram is for carbon, respective mass I found out, then I find out the mole atom, then it is the find out the ratio. It is not a very tough sums. Hope you have followed it. This is the last sum I have done. You try to solve all them. Any problem, next day I will make more such video.